Hey, what's going on, everybody? Happy Tuesday. Hope everyone's having a good morning, afternoon, evening, no matter where you are. Welcome, everybody. Hug me, I'm scared. We got this. Simicam has still not been brought back. I'm offended. It's coming. It's coming. What's up, everybody? How y'all doing? We had some folks last stream, BB Tone, thank you for the 100 bits last stream. It came in right after we went offline. So thank you so much for that. And for the stretch. Accordionette, hey, thank you for the 5 months of Prime. Spending all those Bezos bucks. Thank you so much. I appreciate you. Thank you for being here. Medium Fry, thank you for the 3 months. Let's go. Ooh, Dab Gang in the building. So close. So close. 45. We need 50. 50. If you have a little bit of time before this stream, the Bolical streams right before us, you should be there doing some awesome review, doing kind of code reviews, things that will help you in 100 devs. You should be there before you come here. Join the Dab Gang and come over with that raid. You had 50. Twitch Analytics was wrong. We had 52. All right, we'll take it. We'll count it. A whole lesson on functional programming fundamentals and a lead up to recursion. Whew. Let's go. Twitch took its cut. Hey. Alrighty, folks. Welcome. We got a lot of fun stuff tonight. We got callbacks, promises, async await, node, lots of fun stuff. By the end of tonight, you will be a full stack web developer. You're already software engineers, but by the end of tonight, you'll be a full stack web developer. So tonight we got a lot of fun stuff to get into, lots of code, lots of kind of us talking through ideas, a little less hands on keyboard tonight. Maybe 1 or 2 times our hands will touch the keyboard, but it's a lot of bigger concepts that we need to talk through, work through, but hopefully we'll have some fun. This stuff that we're gonna cover tonight blew my mind. Literally blew my mind when I learned it. I didn't believe anything was real. I was believing in Santa Claus again. It broke me. So tonight, I'm hoping to blow your mind. We're gonna introduce some really fun topics. We're gonna see some code that's gonna help us when we get to the back end, and then we're jumping right into the back end. I have no idea what's going on, but I'm ready to learn backend. I hope that was intentional, Tiny. Thank you so much for the 4 months of Bezos's bucks. Whew, hype train out the gate. Let's go. Ready for this? All right, Speedwagon, I got you. What sounds best? Software engineer, full stack developer? A software engineer that can do full stack web development. That sounds best. Hey, I started 2 weeks ago, and a founder of an edtech company asked to connect and encouraged me to apply. I would never have reached out to someone like that if I hadn't been for your strategy class 2 weeks ago. Let's go. Yes. Let's go. I love it. Folks, we're at 2 out of 100 now. We're at 2 out of 100. 2 out of 100 now. Like I said, I'm not gonna dox folks. If they want to put it in the celebrations channel, they can. But somebody that started with us just started a wonderful apprenticeship, and so we're 2 out of 100, folks. Whew. We're halfway through. 2 out of 100. I'll take it all day long. What's the best resource for data structures and algorithms? I like the MIT course. I think it's a little too dry. But any of them are going to be. I really think that Scotch.io has a wonderful introduction to basic JavaScript algorithms. I like that one. I'd start there. Sam, you got interview number 4 tomorrow. I saw that in the celebration channel. It's wild. That is wild. Will we have any guidance on data structures? Absolutely. As we get towards the end of program, we're going to have lots of classes on data structures, algorithms, CS theory, all the stuff that you're going to need in interviews. I got you. Whew. Sam aiming for number 3. I got to find like cheap t-shirts. Cheap t-shirts that have like numbers on like the shoulder, like 1, 2, 3. Sam, I believe in you. You got this. Bring it home. Bailey, hope I can be someone that posts in the celebrations channel. You will. With time, you'll get there. You'll get there. Alrighty, folks. We got a lot to cover tonight. A lot of stuff. So I'm gonna jump right in. We're gonna get right into it, folks. I think we're just gonna jump right in. We're gonna have some fun. We got a lot of stuff to talk through tonight. I really love this topic. The topics we're about to cover tonight are some of my favorite. My mind literally melted when I learned some of this stuff, so I'm super excited. Ooh, Life is a Garden, your Leon face emoji prize shirt just came in. I'm glad you did. I'm glad it came in. I hope you enjoy it. Recruiters are loving the endorsements on LinkedIn. Thank you all. Hey, let's go. Let's go. Did you hit the bed and sleep for 12 hours after that 7-hour stream? No. I had so much work to get done. This has been a couple of days, folks. I put a lot of effort into kind of our upcoming lectures. We got some big ones coming up. We got the sponsored stream coming up. So I kept working. Sunday's a work day for me. But it was a lot of fun. Everyone that came on Sunday, thank you so much for showing up. We had like our normal numbers on a Sunday, like for a review class. That was wild. Thank you so much, everyone. Need a tank. All right. Oh, thank you so much for the hype train, everyone. I appreciate the support. All right. Let's go ahead and get into it. I'm going to go to Little Leon. I'm going to chill the music here. Thank you for posting the check-in. If you haven't checked in, folks, go ahead, hit that link for me. Give me a like, give me a retweet, please. It's what draws the sponsors in. Alrighty, cool. So let's get into it, folks. Oh wait, the music's still. There we go. Boom, music's chilled. All right, tonight we got some 100 dev stuff to talk about. We're gonna jump into callbacks. We're gonna talk about promises. We're going to talk about Async Await. We're going to talk about Node, and you're going to have some very simple Node homework to get through. All right. So lots to get into. I'm going to break it down as simplest of terms as I can. I want these slides to be something that you come back to, that has short, sweet definitions that explain what's happening, so that this doesn't have to be some mystical thing, something that's really hard to understand when it comes to JavaScript. These things are stuff that we've already been using. Everything we're covering tonight, we've already used. We just didn't know the names or the terminology behind it. So tonight we're revealing the curtain, and we're looking at like what all these individual things are, how they come together. And more importantly, we're setting the stage for what Node really is. Like, what is Node, right? That's what we're setting the stage for. Hey, Purpose, thank you for the gifted sub. Thank you so much. Alrighty. Questions. I like to always give like a minute or so for questions. Any questions before we jump right in, folks? We've been getting some nice chit chat going, but any questions here? How am I doing? I'm doing good. I've been hustling, folks. I've been hustling. Really trying to get some stuff off the ground. I'm really excited for our class on Friday. So on Friday, not only are we doing a prep review on Remo, we're also talking about the agency. So you definitely want to make sure that you show up to our Friday class. It's going to be a lot of fun. Stuff I've been working on this behind the scenes for a long time. I'm going to start putting stuff out there and start getting it moving. So super excited. Doing well. I'm glad to kind of get class going tonight, and then really excited for Thursday and Friday where you start building. Like, we're at the point where we can build real stuff. It's no longer just like simple client-side JavaScript. We can build full stack web applications. I'm so excited for you to get there. Alrighty. Karen said it covered up to the dinosaur article covered up to 2017. So a lot of the big stuff is still covered in that article. I will send out some updated stuff as we kind of progress next week, but that's really a good place to like set the tone, and for seeing all the moving pieces that are part of the ecosystem. A lot of them are still there. What? Anonymous Gifter, thank you for the 5 gifted subs. That's wild. Thank you so much. I appreciate that. Anonymously too. Wow. That's awesome. Balk, I'm glad you're part of it too. Thank you for being here. Alrighty. Hey, Anonymous Gifter. Cheers to you. Thank you so much. Appreciate that. Alrighty. Like I said, this Friday, live prep class. We're walking through parameters, returns, examples, pseudocode, how you can start learning how to practice for your upcoming interviews. You want prep to be something that's innate, something that you do. You wake up, you roll out of bed, and you're prepping already. All right. So we're going to drill it. We're going to practice it. We're going to make sure that when you're in an interview, you're stone cold, a lean, mean interviewing machine. And that practice starts on Friday. We'll also have our office hours on Sunday, normal office hours. You come with questions, I give answers. We stop when the questions stop coming in. So hopefully see you all on Thursday to keep the node train going. Friday, come practice how to interview and the things that you need to start putting in place like now so that you're ready when you actually have the interviews coming in the door. Then Sunday, we have our office hours. Cool. Is Friday an hour? Yes, it's an hour. We're going to be on Remo. I'm going to go live. I'm going to answer some coding challenges live so you can see how prep works. Then we're going to get some froggy folks that are ready to leap to come up and try it as well. And then we're going to break off into one-on-one sessions so that you can practice prep with a partner. So it turns out clocks have gone back an hour, missed the raffle, but present for the stream. Oh, what raffle were you talking about? Are you talking about the secret raffle? The secret raffle that was part of the newsletter? Yes, that's right, folks. That is right. If you opened the newsletter, there was a secret raffle for a Micro Leon sticker. You might have missed it. It was only open until stream started. Got to open the newsletters. There's always surprises. Surprises afoot inside of that newsletter. ! Newsletter if you would like to join. Alrighty. Some big changes happen afoot on our Discord channel. Some pretty important changes. So we're almost at 3,000 people on the Discord. That's a wild amount of folks to be on one Discord community that's as active as we are, sharing as much as we are. So we have 2 new channels that are really important. The first channel is our stream team, which is in the 100 dev section. This is for folks that are part of the team that are going to announce when they're going live. If you're part of the Dab Gang, you're going to see the announcements go live there. If you would like to be part of the 100 Dev stream team, you can use this Google form to give me your information. I'm going to set up kind of like one-on-one talks with everyone just to like walk through some of the rules of joining and make sure you get set up on that channel. Cool. So if you would like to join the elite community, currently including the debacle and all the wonderful things they're doing right before this class, you should fill out that form to join the stream team. Now, part of our rules since the beginning has been that you shouldn't be posting your Twitch or Discord links or anything like that that would kind of split up the community. And so we've really never honestly super enforced those rules. But since we have so many new folks and so many folks that are kind of just joining to post and then not really being part of the community just because we're big now, we're going to start enforcing those rules. Both myself and the moderators are going to. So there's two places if you want to share that type of content. You can join the stream team. The perks of joining the stream team is that we're going to encourage folks to turn on notifications so that when you go live, folks get a notification that you're going live. But for anything else, if you want to share your YouTube, you want to share your Twitch, you want to share a blog post that you wrote, something fun that's not really even 100 devs related, that's totally okay. We now have a self-promo channel. So there's a self-promo channel in the main channels on our Discord. So if you have anything that you built that's yours that you want to share, you can go ahead and put it in the self-promo channel. Now, if that content is posted anywhere else, we're going to delete it and probably do a kick. This is just going to help us combat spam over the long run because now we have thousands of people. So if you have like personal stuff you want to share it in the self-promo channel. If you would like to join the stream team so that folks, a part of our community, can know when you're going live, fill out that form. Thank you, finally. So please help us keep the channels clean and use those two channels. If you have any questions, always feel free to use ModMail to let us know. No, Chris, you can definitely share like your projects and stuff like that, but it's more for like folks that aren't part of our community that stop by and say, hey guys, today I'm doing this thing. And then they never contribute anything else to our community. We don't want that, right? So we have a place for it now, which is the self-promo channel. And if you want to be more involved and do more things that kind of help enrich the folks that are going through 100 devs, you can join the stream team as well. Yeah. So that's all. It definitely feel free to share like your code and the things that you're working on. That's totally fine. It's more for, like I said, the cheeky folks that pop in, post something, and then they don't ever come back. Like, we don't want that. There's a self-promo channel if you want to do it. But we're hoping that we can build out the stream team. And as you're building really good content, we can find ways to highlight you. Cool. If you spam, you better scram. Alrighty. Thank you, folks. I appreciate it. Like I said, newsletter. There was a random raffle today. 30 folks got into the raffle before the stream started. Now there's like over 50 plus. But when the stream first started, there was 30. So what we're going to do real quick is we're going to open up an inspector. We are going to go ahead and do our normal math.ceil. We're going to put a math.random in here. And we are going to do times 30. Jared, hey, thank you so much for the sub. Appreciate that. 3 months. Let's go. All right. Thank you so much for being here. All right. So we're going to go ahead and run this because there's 30 before the stream started. Now I see all y'all flooded in now. Too late. Next time, open it up. All righty. We have 1 through 30, so that's why we're going to do the ceil, just going to round up. And then, so I'm not going to show this on stream just because I don't want people's like personal information. I don't want to dox anyone like live on stream. So this is one of the weird ones where you're going to just have to trust me that you were this person in line. So let's go ahead and do it. 28. Hold on. Let me see who that was. $28. Topher tries. You got the sticker. Topher tries. Send me a message on DM on Discord, and we'll get that sticker coming your way. I got to figure out a way next time so that I can do it live on stream. But yeah, maybe we'll put like, what name do you want on stream? But Topher tries. Congrats on the secret newsletter sticker raffle. Now, like I said, newsletter, always the cool stuff comes first there. And we're eventually going to be putting a free laptop raffle in that newsletter. So a big one's coming up soon, folks. We had 2 Pokemon raffles that we had to do. Let me pull those up real quick. Actually, we're going to hold off on the Pokemon one for a second. When we take our break, I'll pull it up. But we have 2 Pokemons that we have to get to that we're going to go over today. So when we take our first break, when we come back, I'll do the Pokemon raffle. I forgot to pull it up before stream. All right. Remember, this is a fresh start, folks. All your sins have been forgiven, right? You can join us fresh. You forgot to turn stuff in. That's okay. Come on back. And let's jump into the back end together. Alrighty. Knox, yeah, hey, congrats on the interview. Fingers crossed, let's go. Alrighty. Remember, networking is back in action, folks. I'm asking for 1 coffee chat again this week. Just one. Just one little coffee chat. Just one teensy little coffee chat. That's what I want this week. So for your networking, 1 coffee chat, please. If you need an alternative, if for some reason the networking thing is something that's causing you mental anguish, it's something that you physically can't do, let me know. We'll find alternatives together. But I'm looking for 1 itty bitty coffee chat. All right. Make sure you're using the sheet still. Make sure that you are using it not only for your own networking, but if you're taking a stab at building out that hit list, make sure you're using the sheet. That way you can keep track of all of those leads. The checklist stuff was due today for homework. And so I'm going to have the link to submit everything. It was in the previous follow along materials, but if you haven't grabbed the checklist, if you're new, this is all the stuff you need to start putting in motion to be ready to start interviewing. And so make sure you grab the checklist. Remember, you should be pushing every day, folks. Yes, every day. Recruiters love those green squares, right? Those green squares they love. Make sure you're pushing every day. Leon, are we starting the networking sheet from scratch? Yeah, because it's totally for you. So if you already had one going, don't restart it. But if you're new and you need to start your networking sheet, then you should definitely just grab it and start filling it in. It'd be nice if people didn't ghost. Yeah, it's a problem. The new one is the same thing, just with a new tab. So you can just copy and paste everything over and it should be fine. How do we delete accidental future pushes? Like pushes you're going to make, like you haven't written the code yet? I'm not sure. That's interesting. Or like you have your code ready, but you don't want to push the stuff you committed. I think maybe that's what you're asking. Remember, there's a good website called Oh Shit Git. Oh Shit Git has like all the answers to a lot of those like common problems with really good code examples. So I would check out Oh Shit Git first because I'm pretty sure they have an answer to that specific question, if that's the question you're asking. But if you don't find it there, post in our general code help channel and just at me, and I'll show you how to do it. Thank you, Akela, for posting the link. All right, submitting your work. There is a Google form that I would like for you to use this evening. It has links to all the stuff I care about, all the stuff that was in the checklist. It has places for you to link your things. So I'm looking for all the stuff from the checklist. I'm looking for the description of your 100 hours project. I'm looking for like a link to your Code Wars repo. All that stuff is inside of the Google form. So for your homework submission, please fill out that form and submit it. That way I have everything. Cool. Alrighty. What if we couldn't finish everything? Fill in as much as you can. Yeah, fill in as much as you can, and then you can resubmit once you finish. I got you, Memphis. Alrighty. No worries, Brian. Hope the interview went well. Alrighty. Alrighty. Remember, folks, we're entering into a new era. The spaced repetition is now important more than ever. You should be prepping the bank. If you have free time, you should be doing your coding challenges using prep, and you should be prepping the bank. The bank, exclamation point, the bank, I believe, here in chat, are all the behavioral questions and technical questions that are going to help you excel in an interview. So please make sure you're putting these into your Anki. I really prefer that you build out your own Anki and have the active recall through the material. You digest it all. You find the sources that make sense to you. But there are quite a few Anki decks circulating on the Discord if you just want to jump in and start kind of grinding out answers. All right. Tonight, folks, we're diving into the back end. We're diving into the back end. I'm so excited. We're diving into the back end. But first, let's deliver some papers. We're going to deliver some, before we get into the back end, we got to deliver some newspapers. Yeah, like my internal 9-year-old was like really excited for me to use that term. Yeah. All right, we're going to deliver some papers first. So I want you to imagine that you are a paper delivery child or a person, and you have some newspapers to deliver around the neighborhood. If you're of a certain age, the newspapers were these like dead pieces of trees that they would print news on and then deliver to your house. And people would wake up in the morning, they'd go grab these dead, like this bundle of dead trees. They would open it up and then they could read like all the news. Kind of like, I don't know, kind of like Reddit, but like on dead trees. So, pie. So let's imagine that we are a paper delivery person and we have to deliver some papers, right? Every morning we get up and we have to deliver some papers. Now, we can be a really good paper delivery person, or we can be a really bad paper delivery person. A good paper delivery person would probably be asynchronous. But let's imagine that we are a synchronous paper delivery person. We're going to take our newspaper, we're going to throw it out the door of the house that we're delivering to, and then we're just going to wait. We're just going to sit there and wait. Eventually, the person wakes up, they put their slippers on, they come down the stairs, they open the door, they grab the newspaper, they wave to us, we wave back, and then we cycle 2 feet forward, and we throw another newspaper at the next door, and then we wait. Anyone remember the game Paperboy? Whew, what a good game. And then we'd wait. We would be the worst paper delivery person in history if we waited at each door for the person to wake up, put on their slippers, come downstairs, and grab the newspaper. Now, what we really would hope that as a paper delivery person we'd be doing would be that we were asynchronous, meaning that we were throwing a newspaper at the door and then just moving on to the next house, throwing that newspaper at the door, moving on to the next house. Now, the difference here being that we're not waiting to see if the owner got up, put on their slippers, came downstairs, opened the doors, and grabbed the newspaper. Most of the time, the newspapers are going to be delivered just fine. There might be some times, however, where errors arise. Somebody stole the paper. The dog stole the paper. It rained and the paper got wet, right? Right? So the idea here is we could either be synchronous, where we're like waiting and then moving on, right? Or we could be asynchronous, where we are kind of like moving on to the next house, right? Cool. So keep these paper delivery persons in your house, in your mind. Are we going to be waiting at each door? Or are we going to be moving on and going on about our day and finishing our paper route? Okay. Now, JavaScript is something called single-threaded, meaning that it is synchronous and it processes one operation at a time. So we can think of single-threaded as just one paper delivery person, right? We have one paper delivery person and they're going to deliver all of the papers. We could be multi-threaded, where we had a bunch of different paper delivery people all running around the neighborhood, right? Delivering newspapers, but that can cause some other problems that we have to worry about. So for now, we're going to worry about JavaScript being one paper delivery person and having to do all of this work. Now, if JavaScript is synchronous, meaning that each thing we do, right? Each thing we do is going to stop and wait, right? Like we're gonna throw the paper at the door, and then we're going to wait until that person wakes up, comes down, and gets the paper, right? How do we do anything that we normally do in the browser? How do we make API requests and keep scrolling around? How do we load images and keep clicking on stuff? Like if we had to wait for every single thing that we did in the browser, right? If we had to wait for every single thing that happened in the browser, it would be a horrible experience. We don't want to have to click a button and then like wait to like scroll down, right? We don't want to like something on Instagram and then have to wait as we're like scrolling through other images. There's a lot of stuff that we're doing that is asynchronous. But if JavaScript is single-threaded, if it is synchronous by nature, then things should block. We should be stuck waiting, right? We should be stuck waiting for stuff to happen, for stuff to load before we can do anything else. Imagine like having to load an image and like waiting before you could click a button, right? That would be just a horrible experience. But JavaScript is designed out the gate to be synchronous, to like do one thing at a time, right? Indifferent welcome. No, we didn't start early. Time change. I'm glad y'all showed up. Time change. Alrighty. So, Leon, you're telling me that JavaScript should block, like it shouldn't be able to do stuff asynchronously, yet we are able to do stuff asynchronously, meaning that we're not just sitting there waiting for stuff to happen. We're able to click and move on. We're able to make an API request and move on, right? We're able to do all of this stuff, yet we shouldn't be able to with JavaScript. And this comes down to the environment, right? This comes down to the environment. Now, when I'm talking about the environment, I'm not talking about like the environment here on Earth, right? I'm talking about this, baby. I'm talking about this right here. I'm talking about this right here. This is an amazing GIF. I need this. Like, this needs to be like my wallpaper. So we're not talking about the Earth. We're talking about this. Our JavaScript is running in a browser, right? So the environment that the JavaScript that we've been writing, the JavaScript that we've been consuming, has all been running in a browser, okay? So the environment in which our JavaScript code has been running has been in a browser. And this is really, really important because browsers have a bunch of APIs that can handle all the asynchronous stuff that we want to be happening. JavaScript can't handle it itself. But since we are running JavaScript in the browser, we get access to all this really cool stuff that's really good at running stuff asynchronously. Right? Since the browser is a program, the browser is a thing. It's an environment where we're running our JavaScript, and that environment, the browser, has all of this code that we can use, all of these APIs that make doing asynchronous stuff easy and actually doable, right? And if you click that link, there's a lot of them. There's a heck of a lot of these things. And some of these are really interesting. Looking at this right here for a second. DOM. DOM is part of these web APIs. Browsers have a bunch of web APIs that are asynchronous, like they can do stuff asynchronously that JavaScript can't do. And these APIs actually enable us to do the cool stuff that we're used to doing in the browser. We can look at our cute cat photos and still be clicking on stuff as asynchronous stuff is happening. So when you click that link and you look at common browser APIs, you see the DOM, the Document Object Model API. And you're like, wait a minute, hold on. Let's slow down here, Leon. What's going on here? Wait a minute, hold on. Leon, DOM, Document Object Model API. This is literally probably the thing I saw 10 years ago when I was trying to make heads or tails of all this. Like, this is like, I'm walking you through the experience I had when these things started happening. Okay. So let me get you to where I was 10 or 11 years ago. I just found out that JavaScript isn't really good at asynchronous stuff. It can't really like do one thing and then keep moving on. And then once one thing finishes, we're good, right? Like think of like we're a paper delivery person. JavaScript, the only thing JavaScript can do is throw a newspaper at a door and then wait until that person gets it. And then they move on to the next door. It's blocking, right? Yet the browser, right, is where we're running our JavaScript. And the browser where we're running our JavaScript actually has all these things that enable asynchronous stuff to happen. Like think about all the stuff we do in the browser, right? Like we make a request to an API, that data comes back. But while we're waiting for that data to come back, we can still like click on stuff and do other things, right? And so the browser, the place where we're running our JavaScript, actually gives us access to all of these things that JavaScript itself does not come with. Okay? So that's where I was at 11 years ago. And I probably read this exact thing on Stack Overflow I'm about to read right now. The DOM, the Document Object Model, is essentially the API one uses to manipulate an HTML document, usually using JavaScript. Hold on one second. Stay with me. The DOM is essentially the API one uses to manipulate an HTML document, usually using JavaScript. Usually? Hold on. I've been using only JavaScript to manipulate the DOM. Like I use JavaScript to like put text into the DOM. I use JavaScript to set up like my Smurfs that listen to clicks in the DOM. I use JavaScript to like delete stuff from the DOM, add stuff to the DOM. But wait a minute. Usually using JavaScript. What the fuck? Wait a minute. Hold on. We had a hydration. Lank Ant, thank you for the hydration. Cheers to you. Wait, what the fuck? Miss QQQQ, thank you for the hydration. Cheers to you. Hold up. Wait a minute. What the fuck? Usually using JavaScript. So that means that I could use something else other than JavaScript to manipulate the DOM. And this is where I start to realize that JavaScript doesn't come out the box with the ability to manipulate the DOM. So all this code we have been writing wasn't actually JavaScript. It was a web API that we were consuming or using via JavaScript. Yes, that means document.querySelector, the thing that you have all probably have written 100 times, 1,000 times, that's not like vanilla JavaScript. That is a web API that we use when we are running our JavaScript in a browser. Browsers give us access to these different APIs like the DOM, the thing that we've been using this whole time. But that's not actually part of JavaScript. We only get this when we run our JavaScript in a browser that gives us access to that stuff. What? What the fuck is going on? I thought I was writing JavaScript all this time. I mean, I was writing JavaScript, but the things that I thought were JavaScript weren't all part of JavaScript. So yeah, JavaScript can do a lot of blocking stuff in the browser because it's handing all of those blocking tasks off to some asynchronous web APIs. So JavaScript itself can't really do this asynchronous stuff, but it's handing all this asynchronous stuff off to the browser web APIs. Those web APIs do their thing asynchronously, right? And then they can respond back to JavaScript. Let's step back here for a second. So, our JavaScript is running in a browser. The browser gives us access to a bunch of these APIs. These APIs give us a lot of functionality that we're just used to using, right? We just take doing document.querySelector for granted, but that's not actually part of JavaScript. JavaScript is a programming language that when ran in a browser has access to this extra stuff that the browser is providing. And one of the things that the browser is providing, like one of these very common APIs that the browser is providing, is access to the DOM. Like the ability to like put stuff in and take stuff out of the DOM, to hide stuff, right? That wasn't JavaScript. Like JavaScript, like if you read like the base programming language that is JavaScript, there is no document.query selector. That is an API that we are consuming. All right? This is an API we're consuming. Debacle said, so is this why we have cross-browser compatibility problems? Yes. This is where a lot of these cross-browser problems came up if you go back 10 plus years, right? If you go back 10 plus years, not every browser was exposing the same APIs. So the JavaScript you would write for one browser might not run in another one because it might not give you access to these APIs. What? There was something that was created to help solve that problem that made the JavaScript cross-browser compatible, and it became really, really popular for a while. Anybody know what that was? Yeah, Destroyer. Exactly. It was jQuery. All right? It was jQuery. Indifferent. They're not ready for that yet. Indifferent. It was jQuery. jQuery was made so that it could fill in some of the gaps between the different browsers, right? jQuery was created to say, hey, like maybe this browser you're trying to use doesn't give you access to this stuff, but if you're using jQuery, you can just use it, right? Then the browsers caught up, the W3C caught up, the technical council behind ECMAScript caught up. Then that means JavaScript caught up. And now most of the browsers are kind of in agreement. They kind of all expose very similar, like all the similar stuff. And we don't really need jQuery that much anymore. But for a long time we did. Because the language that we know as JavaScript didn't really come with the stuff that we were using, the stuff that we were using every day in the browser to do the things that we were doing. It didn't come with. Life is canceled. Nothing is real. Purpose. JavaScript is running in a browser. So JavaScript, the language that we know and love, is running in a browser. And when JavaScript runs in the browser, it gets access to a lot of these common web APIs. These things that enable us to do really robust things. A lot of things that we would consider what we call asynchronous, that are kind of happening in the background. That all comes not from JavaScript, but from running in the environment. And the environment this time is the browser. Yeah. Alrighty. So that means that technically, since JavaScript is decoupled from the DOM, like editing what we see rendered in the browser, you could write any type of scripting language that you wanted to manipulate the DOM. Like they're decoupled. Like you can figure out how to make Python work with the DOM. You could figure out how to make Ruby work with the DOM. You could figure out how to make any different types of languages work with the DOM. And people tried it. People really tried it. Destroyer's putting some fancy tidbits in the chat there. Where this kind of came to a head was Netscape Navigator, one of the first like real big browsers. They were tasked, like one of the engineers was tasked with making a scripting language. They made a scripting language. That scripting language then went on to become like JavaScript. But there are some real weird turf wars in between where Microsoft was saying like, hey, I'm going to make LiveScript. And then, all right, if you're going to make LiveScript, we're going to make our own browser. Then Firefox gets started. JavaScript comes together. There's like a 10-year period where everything's just going to hell. And then this council comes together. There's like this ECMAScript thing that comes. It's a wild story. I'll post the whole story in our Discord after class. But it got real wild for a minute, folks. It got real wild for a minute. Matthias, hey, thank you for the hydration. Cheers to you. It might have been JScript. Yeah. Yeah. Cool. I'll post the whole. It's a wild story. All right. Usually. All right. So we got to think about this for a second. So JavaScript, which should be blocking on a lot of these tasks that we do every single day, right? Like all the things that we think are happening, like all the things that are happening asynchronously, JavaScript should block on. Like it shouldn't be able to handle those things, right? Fox, thank you for the hydration. Cheers to you. It shouldn't be able to do a lot of these things. But it's able to do these things because JavaScript is running in the browser and it's handing off some of that asynchronous stuff to these web APIs. These things that are built into the browser that are really good at handling all the asynchronous stuff. And this leads us to a new problem. If we're handing all this stuff off to these web APIs, eventually we're going to need to handle a response that comes back from those web APIs. Like if we're sending all this stuff off to a web API and that web API does its thing, eventually needs to come back and tell us what happened, or come back with some data, or come up with some updates, or come back in some way, shape, or form. And so if we are handing stuff off and we're expecting responses, we need ways to handle these responses. We need ways to kind of handle some of this asynchronous stuff that's happening. And JavaScript does this with callbacks, then promises, and then eventually async await. Okay, so that's what we're going to get into. We're going to talk through these couple of things, and then this is going to lead us into an idea of like, all right, well, if that's what JavaScript was in the browser, then what could JavaScript be elsewhere? And that's when we're going to get into Node. Now, there's a lot of stuff here that we're not going to talk about tonight. Right? We're not going to talk about call stacks. We're not going to talk about the callback queue. We're not going to talk about how these web APIs are doing this wonderful stuff. We're not going to even really talk about the event loop tonight. But we will on Thursday. We will on Thursday. So all this like really technical stuff, I'm not covering tonight. Right? We'll come back to that on Thursday. We'll hint at it. I don't want to overload folks. I want this to be a gentle introduction. It just exploded your minds. Like when that clicked in my head, and I figured out that JavaScript only had access to the DOM because it was running in the browser, and that wasn't part of like the actual language. My mind just like melted. I needed to walk away for a minute, right? Like I needed to like take a breather. So I hope your mind, right? I hope your mind was melted a little bit. I'm not going to take it deeper into this stuff tonight, but on Thursday we'll have a chance to. What do I mean by blocking? Let's take a look at it. Blocking just means that you're waiting. That's all I'm saying. Let's just reduce blocking to waiting. Like, I don't want to have to wait, right? If I'm delivering newspapers, right, I would be a really bad paper delivery person if I delivered one paper and then blocked. Like I just waited for that person to come and pick up the paper. That would suck. I'd be fired same day. Same day I would be fired if I threw the first paper and I blocked and I stopped. Right? I'd be the worst paper delivery person ever. I'd be fired same day. We don't want to block. We want to be able to throw papers at every door and keep moving. We don't care if that person kind of comes downstairs and gets the paper. When they get the paper, we know eventually they'll come get the paper. But we're not going to block and wait. We're going to keep it moving. All right. So let's deliver some papers. If you download the starter code today, there are 8 different pieces of code that we're going to be using today. And so I'm going to uncomment this first bit of code here. And I already have it open so that I can run it. But here is some very nice code here that is synchronous. It's going to go one after another. And so let's go ahead and run this in the browser. Let me go ahead and refresh. And you can see in the browser, we delivered to the first house, then we delivered to the second house, and then we delivered to the third house. And we can see that code here, right? We have three functions. House 1 has a console log, says delivered to house 1. Function house 2, paper delivered to house 2. House 3 has paper delivered to house 3. Cool. I can call those functions one after another. Nice and easy, nice and synchronous. We read top to bottom. House 1 runs, house 2 runs, house 3 runs. Everything as normal as we would expect it to run in JavaScript. Now, let's go ahead and say we are going to use a web API. Set timeout. We're going to use another web API. We already saw document.query selector. We're going to use another web API. Set timeout. Yes. This broke my brain when I figured this out too. Set timeout and set interval are not part of the JavaScript specification. They're not part of JavaScript. But most environments where we run our JavaScript give us access to them. So in the browser, set timeout, set interval, these are web APIs, right? And we're lucky that most browsers implement them, including, or say, let's just say most environments. Like the browser is the environment we're used to using. And so most environments include them, including the browsers, and thankfully also Node when we get there, right? Now, this broke me a little bit when I first found this out, right? But it makes a lot of sense. If JavaScript is synchronous and it doesn't really handle asynchronous tasks, then something like a set timeout that runs, takes some time, and then does something probably really wouldn't work that well with JavaScript. So what we do is we hand off that behavior to a API. In this case, a web API. Set timeout is a web API that every browser, well, I'm going to say mostly every browser has access to, right? And then we can use them because the environment where we are running our JavaScript has access to those web APIs like set timeout, set interval. What the fuck? This destroyed me when I first found out about this. All right. You got me. This was live footage of me figuring this out for the first time. You got me. All right. I thought it was JavaScript, but it's a web API. You got me. All right. So let's take a look at this real quick. And then we're almost at the top. We're at the top of the hour, so we're going to take our break. Let's take a look at this code now. So here we have the normal code that we just saw, except we're also now using this web API set timeout. And if you don't know what set timeout does, is it runs this function after this amount of time. After this amount of time. So after three seconds, this is milliseconds. So after 3 seconds, this console log should run. All right. So let's go ahead and see this live in the browser. If you're new and you need the starter code, you can do !Discord, join our Discord, agree to the rules, and all the starter code you see live here, you can access in the follow along materials channel. So I'm going to uncomment this. Let me save, and then I'm going to run this in the browser, and we're going to see what happens. All right. Paper delivered to house 1, paper delivered to house 3, paper delivered to house 2. Chat, what happened here? Yeah. Exactly. Did JavaScript wait? Did JavaScript wait at all? Nah. It's like, nope. Got a mission to do. Got to keep going, right? Nope. Get out of here. Not happening. Nope. So what happened here is we ran the first one. We ran the second one, but that handed something off to a web API. And then immediately, the third house ran. And then eventually, sometime later, this finished, and we saw that console log. Right? So it just didn't care. It just kept on moving, right? Just kept on moving. Handed that off, kept on moving. Did not care. Now here's something really interesting. Here, the delay is 3 seconds, or 3,000 milliseconds. 3,000 milliseconds is 3 seconds. Here the delay is 3 seconds. Let's take a look at this. Sour Dev, hey, thank you for the sub. I appreciate that. Thank you for being here. Let's look at this. This delay is 0 seconds. So no delay. No delay by today. No delay. Let's go ahead and take a look what happens when I change 3,000 to 0. You ready? Saving this. I'm going back. I'm going to refresh. 3, 2, 1. Hold on. Let me refresh one more time. Let me refresh. There's 0 delay. No delay. By today, no delay. Let me refresh. 1, 3, 2. What? Got him. Oh. Got him. Got you all. Got you all. Chat. Why did we just get got? Why did we all just get got? Yeah, some folks did some reading here, right? Remember, this right here is a web API. We have handed that off to the web API. We've put this on a stack of sorts, right? We've put this somewhere else. The check, right? The check still has to occur. It still has to check to see like if something has happened. That check comes after, right? The check to see if this is done, even though it's 0, since it was passed off to the web API, the check to see if something was done, right? That comes after. So even though it was 0 seconds, the check to see if it's done comes after we're able to run this third function. And so that's why we see in the console 132. Now, there's a lot of kind of technical things that are happening here that we can talk about that's all relating to this thing called the event loop. And we're going to get into it on Thursday. So on Thursday, we're going to dive deep into it, what's actually happening here. It's something really neat. It's one of the coolest things I think about when you're learning JavaScript and Node for the first time. And so I know it's weird right now, but we're going to dive deeper into it when we come back on Thursday. But it's something called the event loop. If you got through some of the reading, you would have seen and talked and heard about it. You would have heard of things about like call stack, a call queue, an event loop, and you would have understand how those things are being passed off. But what I want to do is I want to take a break. We're past the top of our hour. So let's go ahead and take our 5-minute break. I'm going to put a 5-minute timer on the window here. I know your brains have been blown tonight, so take your well-deserved 5 minutes. Gonna put some break music on for you. Go ahead and take your 5 minutes. We'll be here when you get back. I'm gonna run some quick ads just so that new folks joining us don't get ads when they try to join the stream. So those are gonna go live right now. I agree, indifferent. What are environments besides the browser? Oh, that's an amazing question. We're going to see another environment today. I'm going to show you another environment that's not the browser. It's going to be it's kind of what we're talking about today. Topher with the 2-minute extension. All right, when this gets to 4, it'll be 6 minutes. Boom. All right, there we go. 6 minutes. I think people appreciate the extension. Raw yolks. No, we didn't start early. The time zone has changed. We have daylight savings time in the U.S. If you're not from the U.S., maybe you might not have daylight savings time where you are, and so that's why it might look like a different time. Yeah, I honestly didn't think about that. I should have made an announcement. Yeah, not everyone has daylight savings, so it might have looked like the times changed. How do I get code to run from VS without copy and pasting into the console in Chrome? You can, well, the open in browser, you would open an HTML file. You have to open an HTML file, not a JavaScript file. So make sure you're doing the open in browser on the HTML file and not the JavaScript file. Eventually, after today, you'll be able to just use Node directly in the terminal to run your stuff as well. Izzy, it's just your hit list that you're using now. Don't worry about the word complete. It's just whatever hit list you're using now, because we updated it. There should be like 2 tabs now. SK2Q, hey, thank you for the 4 months. I appreciate that. Thank you so much for being here. It's up to you how you want to install Node. I'm just going to have folks do the normal, just like install directly from the Node.js website. Yeah, there could be lots of other ways to do it. I think that's just the easiest for the most folks, so we don't run into really wild stuff. Raw yolks, JavaScript is a lie. That's what we learned. JavaScript's a lie. JavaScript is a language that is running in an environment called the browser. And that browser gives us access to a lot of stuff. The stuff we've been talking about are called web APIs. And so things that we just thought were part of JavaScript, like document.querySelector, set timeout, set interval, those aren't actually part of JavaScript. They are given to us by running JavaScript in that specific environment that is the browser. Bugaboo, yeah, I'll check it after stream and add new folks. And JavaScript isn't even a language. That's lies all the way down. Oh boy. Wait until we get to that. dope. Diabolical, throw that on the self promo channel for sure. I want to build a point of sale system for restaurants as my 100 hours project. Is that feasible? As long as it's very, very tightly constrained, it could be doable. All right, folks, you got 2 minutes, 30 seconds left. If you're able to, stretch, hydrate. We'll be back in 2 minutes. 2 minutes. More fun to be had. More fun to be had this evening. Alrighty. Yeah, Serpino is the daylight savings, unfortunately. Sorry, BB Toad. Thank you for the hydration. Cheers to you. It was the timer came in right after it. Thank you for the hydration. I've just felt a new wrinkle grow in my brain, making neural connections. Hey, let's go. Hey, I had to miss the review class on Sunday. Yeah, absolutely. Catch up. Jimmy, that's hilarious. Chaos mode. Yeah, that's what we're building up to. That's what we're building up to. Somebody already used the 2-minute extension. Oh, Diego with the posture check. Thank you so much. Peace, Sam. Hope all is well. Yep. And JDB, it's already here on the VOD. So if you just want to check the VOD, you can. And it'll go up on YouTube soon as well. Are we doing any more YOLOs? Maybe on Thursday we'll do a few YOLOs. Interesting. Alrighty, folks, come on back. Come on back. Hope you had a good break. Hope you're able to stretch, hydrate a little bit. Alrighty. I'm gonna chill the music here. And let's jump back into it, folks. Ooh, that sounds pretty good, Nage. Alrighty. Let's start talking about some stuff here. Let's say, all right, folks, what if it's payday? What if it's payday? I only want to move on to the third house after the second house has paid me, right? So like I'm at the second house, but I don't want to move on until that house has paid me, right? Like I don't want to move on to the third. I want to wait until I get paid, and then I'm going to move on. Okay. In the real world, this might be like getting data back from an API. Like you don't want to put, we ran into this a few times. Like we wanted to like wait until we got data back from an API and then use that data somehow, right? Sometimes we got stuff, we were trying to get stuff back from an API, but our code ran too fast and we didn't get the data back before we tried putting it into the DOM, right? So let's pretend I want to get paid. I don't want to move on to the third house until the second house has paid me. So how do we do this? Well, one of the old school ways to do this is with something called callbacks. So callbacks have been the old way of kind of saying, you know what, don't want to move on until I've gotten paid. All right. So here's something about JavaScript and some other languages. In JavaScript, you can have a function that takes another function as an argument. You can have a function that takes another function as an argument. So we call this a higher order function. Any function that can take another function as an argument, we call that function a higher order function. And you have already seen this a bazillion times. You have seen higher order functions all day long. Add event listener is a function, a method. It's a function. It took in click as a property and as an argument, and it took in a function as an argument as well. Right? So a higher order function is just a function that takes in another function as an argument. You've all done this. Every single person has done this a bazillion times. You just didn't know that we would call that a higher order function. We had this function that took in a function as an argument. So in this case, if we had like a click event, we would click on something and then that function would run, right? A callback is the function that has been passed in as an argument, right? So the reason why I use the word callback here, right, is because we know this is going to be a function, but since this is the function that was passed in as an argument, we call that a callback. Okay, it's just the function that's being passed into the other function, right? Now the function that accepts that function as an argument, we call that a higher order function, and the function that's being passed in, we call that a callback. Now it's important to realize that like a callback is not as we're learning tonight, folks, it's not really a thing. It's more of a convention. It's like a thing that we do, not necessarily like something that's built into JavaScript. It's not like a thing. It's just like a conventional way of doing something. All right. Let's get paid. Let's get paid. We're going to get paid by the second house before we move on to the third house. So let's use callbacks to only move on to house 3 once we've gotten paid. So here's the code. I'm going to go to the starter code that I've shared with y'all. I'm going to comment this out, and I'm going to open up the code that has my callback. Let's go ahead and see it first, and then we're going to come back and talk through it. So if we go ahead and we run this in the browser, we can see first house, we wait for the second house, and then the third house happens. We didn't just jump. We didn't jump from 1 to 3 to 2. We went to the first house. We wanted to wait for the second house, right? And then we went to the third house, right? We used a callback to do this. Let's take a look. All right. Here is our house 1, nice and normal function with a console log, beautiful, right? And we call it nice and normal. Then on the next line, we have house 2, and we've passed in house 3. What does this make, chat? Just by looking at this, chat, what would we call house 2? Just by looking at this, what would we call house 2? Yeah, it's a higher order function. Nice. It's a higher order function. And eventually, that would also mean that house 3 in this case would be the what? Would be the callback. Yeah, so let's see this callback syntax in action. So if we look, here is our web API set timeout. What it's going to do is it's going to wait 3 seconds, and then run this code. So it will console log house2, and then it'll run the callback. And the really cool thing about this, the way that this works, is that we pass in house3. House3 falls into the parameter of callback. And wherever we see callback, we're actually running house3. So this line actually becomes house3. All right? Yeah, we passed it in as an argument. That's really neat. That's some special stuff that JavaScript can do, that it can like take functions as arguments, right? And we've seen this. We've been doing this whole time. We have seen this when we were doing our lovely click events. We were just passing in a function name. And one of the things that you'd run into a lot of times, folks would say, hey, Leon, how come it's not this? How come it wasn't callback parentheses, right? Why wasn't there a parentheses after that function name that was in our click events? Well, if it had parentheses, it would have ran immediately. It would not have waited. It would have ran immediately, right? So the really cool thing about this callback syntax, right? The really cool thing about this callback syntax is that we're passing in just the function name. The function name gets passed in as the argument. And then down here, we can run that function. That's really freaking neat, right? Now, the really cool thing is, when can this callback run? When is the only time that this callback would run? What has to happen before this callback can run? Chat, what has to happen before that callback can run? What has to happen? Yeah. That console log has to happen first, because JavaScript still reads, right? Still reads synchronously, right? JavaScript still reads synchronously. So that console log has to happen, and then the callback will run. So the beautiful thing here is, if we step back and take a look, house1 runs like fine. House2 runs like fine, but we also pass in house3. Now, the set timeout waits. It waits the full 3 seconds. And then we see paper delivered to house2 get put into the console. And then immediately the callback runs. And so the callback that runs is house3. And we see paper delivered to house3. So could you pass in a different function? Absolutely. Right? You could pass in whatever you wanted. In this case, we said, you know what? We don't want to go to house3 until we get paid by house2. So when we actually run it in the browser and we take a look at it, it's cool. Like, we see the house1 show up immediately, like it should. Then those 3 seconds pass. We see the console log from house2 get put into the console. And then we know the callback fired, which is why we then see almost immediately after house2, the console log of house3 show up. And so this is a callback. We're able to have higher order functions that can take in other functions as arguments. Our arguments that are functions are called callbacks, and we can use them to do fun stuff like this, where we're gonna wait until we get some result, and once we have the result, we run something else. Ryan, thank you for the hydration. Cheers to you. Now the question is, why are we using a parameter instead of just calling house3 directly? Well, it makes it a little bit more flexible, right? Makes it a little bit more flexible, right? Makes it so that it doesn't have to be just the house3. It could be anything you want it. It could be any function. Cool. Now, if we kind of take a step back, we were talking about this asynchronous stuff. And we can see here that the callback fired when an asynchronous task or another function was done. So once that set timeout finished, that asynchronous action that was handed off to the web API, once that was finished, then our house3 ran. So that callback fired after something happened asynchronously, right? So this was like the old school way of doing something after something asynchronously ran, right? That set timeout, take a full take your time. Take your time, take your 3 seconds. And when you're done, do this. And that was the beauty of callbacks. Callbacks enabled us to have that control. We could do stuff asynchronously, right? We could do stuff asynchronously. And then when that asynchronous stuff was done, then our next function fired. And that's beautiful because we want to be able to do a lot of stuff asynchronously. And then whenever that stuff completes, we want to be able to do stuff based on what happened, right? And so callbacks were the way we did this for a long time. And let's see what happens if we want to like get paid by everyone. So we want to go to the first house and then wait until the second house. We go to the first house, wait until we get paid. Once we get paid, we're going to go to the second house. Once we go to the second house, we'll get paid, and then once we get paid by the second house, right, we'll get paid by the third house. So let's see what that might look like in some code here. All right. So here are a bunch of set timeouts that are nested inside of each other. And so these set timeouts are all going to run after a certain period of time. So the first one, right, this outside one will run after 5 seconds. Then there is a function inside of that that'll run after 4 seconds. And then there's a function inside of that that'll run after 3 seconds. And so if we're really going to start doing this kind of like waiting for asynchronous code to like run, and then we do something after it, even with like this, like I've simplified the syntax here a lot. Even with like the simplified syntax here, all this nesting, well, welcome to hell, baby. Welcome to callback hell. Welcome to callback hell. This just becomes a hot mess. If we have to do all this nesting, it works. It's how Will Smith did it back in the day, right? It's how Jeff Goldblum had to do it. But it's messy. It's hard to read. And developers have appropriately given this 2 different names. The Pyramid of Doom and Callback Hell. Right? And so we want to escape Callback Hell. We don't want to have all this messy nesting. It works, but we don't want to have to do it that way. Pasta Tofu, thank you for the posture check. Hey, why don't you all do a posture check too? How you sitting? You getting that nerd neck? Hope you're not getting that nerd neck. Ooh. All right, got the posture check. Thank you for the posture check. All right. This GIF is a representation of my month. Telefang, hey, thank you for the hydration. Thank you so much. Cheers to you. Alrighty. So, what if there was a more readable way to handle this asynchronous code? Like after something asynchronous happens, we want to be able to like handle that response responsibly, right? So what if there was a way that was more readable to handle asynchronous code? Well, there is, and we call it a promise. Okay. So what if there was a better way to handle this asynchronous stuff? We call it a promise. Promises came to JavaScript when we got to our ES6. So in 2015, yes, I know. In 2015, we got this newer way of handling like what happens after something asynchronous happens. Okay. Now, the thing I want you to quickly understand is a promise is just an object. We all know what objects are. We've been using objects for a while now. A promise is just an object. Now, this object, right, represents the completion or failure of some asynchronous action, like something that happened, like that set timeout happened, right? The object represents the completion or failure of that asynchronous thing, and whatever value is the result. So it's going to be this one object that's keeping track of, hey, did that asynchronous thing, like, did it work? Did it fail? Did I get some data back, right? This object will hold all of that stuff for us, and we're going to call that a promise. Okay. It's really just an object that may have a value in the future. Because remember, it's like a promise of something in the future, right? It's an object that may have a value. Everything might go horribly wrong and we don't, but it may have a value in the future. But it's just an object. Just keep an object in your brain. That's it. You don't need to think about anything else. It's just an object. Okay? Now, promises can have 3 states. Okay? They can have 3 different states. It's just an object, and there's like, you can look at the state of the object, basically. They have 3 different states. They can have pending, meaning that the promise has not been, like, it hasn't been fulfilled yet, like it hasn't like gotten to the value yet, it hasn't resolved the value yet, and it also hasn't been rejected, so like it's still kind of like waiting, right? A promise can also be fulfilled, meaning that the thing that we were waiting for, like that asynchronous thing, right? That asynchronous thing fulfilled, like it worked, it did what it's supposed to do. Or it could be rejected. So a promise can have 3 different states. It can either be like waiting, pending, it can be fulfilled, or it can be rejected. Right? Now, if the promise is an object, what can objects have? What do objects have? Properties and methods. Properties and methods. Objects have properties and methods. And since a promise is an object, right, there are some properties and methods that are going to come along with it. If it helps you think about it for now, we can think about the state being like a property on that object. It's either pending, fulfilled, or rejected, right? Let's just think about that for now. May not be technically the correct words there, but you can just think about it as a property of being either pending, fulfilled, or rejected. And it has some methods that are tied to it. It's just an object, folks. Come on. It's just an object. It's chill. It's just an object here. Hey, whoa, slow down. Just an object. Just an object. It's just an object. All right. So it has some methods that it can use. Okay. It's an object, so it has some methods it can use. The method that we're going to see over and over again, right? The method we're going to see over and over again is then. That's all it is. It's just a method on the promise object. And the cool thing is that it runs after the promise resolves. All it is a method that like runs after that thing we're waiting for, that asynchronous thing we're waiting for. After that's done, then runs. And the cool thing is, whatever like value the promise has when it's done doing its stuff, like whatever value it gets back, right, is passed in as an argument. So a promise is just an object. It has a state. It can be one of three things. It can be pending, fulfilled, or rejected. We use it, right? We use it as a way that is more readable to handle asynchronous stuff. Like, we know the browser is doing some asynchronous stuff. We need a way of being able to handle what's happening. So we have a promise. It's just an object. And the cool thing about this object is that it has a state. It can be pending, fulfilled, or rejected. And when it's done, whenever it's done doing the thing that it was trying to do, we can use the then method to run after it's done. So after that set timeout is done, then it can run. And the cool thing is, whatever we got back from that asynchronous stuff, that value is passed into that method, right? That value is passed into the method as an argument. We've seen this before. We've seen this before. This isn't new. We've all done this. We've all done this. We've seen this before. Rom, yeah, they're all on YouTube. Exclamation point YouTube. We've seen this before. We've seen this with fetch. We saw this with fetch. So, what do we think fetch gives us? Chat. What does fetch give us? What does fetch give us? Yeah. Fetch gives us a promise. Fetch gives us a promise. It gives us an object. All right. Leon stopped. Leon made fetch happen. It gives us a promise. And cool. So when a promise is done, when it's done doing its stuff, what method fires? When a promise is done doing its asynchronous tomfoolery, what fires? The then. Cool. So what we're seeing here is we know that fetch gives a promise. When would these thens run? When would these thens run, chat? When would these thens run? Yeah. When the promise resolves. I need to do like a TikTok of like where the promise resolves, like instead of where the money resides, like where the promise resolves. Somebody, I'll do it. I gotta create a TikTok. Right? These thens run when the promise resolves. Like when it's done doing its thing, it runs. Right? And the cool thing is, as that promise resolves or finishes, whatever data we got back gets passed in as an argument inside the then. Right? So res is holding that value. And then we just chain and pass that value into data again. Cool. Fetch returns a promise. And the really dirty secret is all these web APIs, they all return promises now. So if you know how to deal with promises, all these web APIs that we talked about earlier that we're going to be using in the future, they all return promises now. So once you learn how to deal with promises, all the asynchronous stuff that JavaScript has access to because it's running in the browser environment, right? All those asynchronous things that it can do through the web APIs, they all return promises. Like when it's done, the promise resolves, it gives us data or values or whatever it may be, right? And so fetch returns a promise. And let's go ahead and actually talk about those three states a little bit more. So we've already seen this before. This shouldn't be something that's scary. You've been using these this whole time. Let's actually talk about how it works. All right. I have some starter code here that I'm going to go ahead and I'm going to comment this back out. Let's try and see if we can see the three states of a promise, okay? Let's see if we can actually see these three states of a promise. All right, here is my code for my promise. I'm going to uncomment it. I just highlight it all and I do command / on Mac that uncomments it all at one time. Light bulb moment. Let's go. Alrighty, so let's look at this real quick. Here is the syntax for creating a promise. It's just new promise and then a function inside of it. And in fact, I'm going to make this really simple to see. I'm going to delete all the stuff that's inside the middle here. Here is the syntax for creating a new promise. It's just new promise. And then it has this lovely anonymous function, or sorry, this arrow function here, right? That has two parameters, resolve and reject. So the cool thing is when the promise finishes or it resolves, you can fire it. Or if something goes wrong, you can fire the reject. But that's just the syntax for creating a promise. So let's go ahead and save this real quick. And what I'm going to do is I'm just going to console log the promise. I'm just going to console log the promise. Okay. Let's see what happens. Let's see what we get. Pending. Chat, why did I see pending in the console? Why did I see pending? Yeah, nothing happened inside of it. If nothing happened, that means nothing resolved, right? You got to go where the promise resolves, baby. Where the promise resolves. We didn't go. There's nothing that happened inside that promise. Nothing resolved, right? All right, nothing resolved. And so let's go back and put some stuff inside of here. So now all I'm going to do is have this lovely conditional. I have a resolve with some text inside of it, and I have a reject with some text inside of it. And so what I'm going to say is if there's not an error, like if there's no error, then go ahead and resolve the promise. And remember, when we resolve the promise, we can send some values along with it, right? And so now let's go ahead and do this thing again where there's no error. The error is false. So we should see this promise resolve. And then we're just going to console log the promise. Cool. So we saw pending. Let's console log it. And now we can see that the promise has been fulfilled. Chat, why has the promise been fulfilled? Why is the promise's state fulfilled? Why fulfilled? Yeah, no error. No error. Nice. No error. Right? It resolved, and there was no error. Right? It resolved and there was no error. So once a promise resolves, it is marked as fulfilled. And chat, what does this look like? What is this? What is this up here? It's definitely an object, but what type of object is it? What does this look like? This looks an awful lot like the objects that come out of the classes, right? It looks an awful lot like the objects that come out of our classes. So that's going to lead you to believe some things about a promise. All right, it's going to lead you to believe some things about a promise. Cool. Let's go ahead and see if there is an error. Let's go ahead and change this to true. Cool. And let's come back and refresh. Cool. We can see that the promise was rejected. And since the promise was rejected, right, we get this, since there was an error, it was rejected. And we see this rejected inside the console log of the promise. Now, something interesting has been happening is we've been looking at the actual object because we have been console logging the promise, right? I've been console logging the promise. So that's how we've been able to see like the actual object every single time. Like we've been able to see that actual object every single time. But what we're seeing down here is us handling the promise, right? That's us handling the promise. If we go back and we look at my code, we can see that here we have the promise, and then we have then. When does then fire? When does this then fire? When does this then fire? Yeah. After the promise resolves, the then fires. And what data, if the promise has resolved, what data in this very specific scenario, what data are we passing through with that resolution? What data are we passing through with that resolution? Yeah, it's the string. Yeah, the message. It's this message right here. So we're passing this data along, right? We're passing this data along. So we know that the promise is resolving, right? It's very clear. It's definitely resolving. Since it resolves, the then fires, right? The then fires. And data is holding this string. Data is holding that string because the then fires after the resolution, and we pass that string in as a value. Cool. Now, the other neat thing here we did is if we have this error as true, right? If we have this error as true, so now there's an error. This shouldn't resolve. And what we see here is that it is a rejected. And we have this string that was console logged. Error, operation has failed. Chat. Why did we get error, operation has failed, printed to the console? What happened here? What happened here, chat? Why did error, operation has failed find its way into our console? Okay, let's take a step back here. Then fires when? Chat, when does then fire? One more time for me. When does then fire? When does then fire? Yes. When the promise resolves. We also have something else really cool that we're seeing right here called catch. When do you think catch fires? When do you think catch fires? Yeah. If it's rejected, right? If it's rejected, then the catch fires. So this is really, really cool. This is cool because now we can have a then if the promise works, and we can have a catch if it doesn't, like if it gets rejected. And this is really cool because we can do things like fetches, right? We know that fetches return a promise, and there are a lot of things that can go wrong with a fetch. Maybe we're trying to fetch some data from the dog CEO API. We're trying to get a dog photo back. If the API is down, what's going to happen to our promise? What is it? What's its state going to be? If the API was down, what would happen to the promise that comes back? Yeah, it would be rejected. And since it's rejected, we can use the catch to let us know, hey, something went wrong. Imran, hey, thank you for the hydration. Cheers to you. That's really cool. So the neat thing here is when we're console logging the promise, we can actually see all three states. When there was nothing, we saw that it was pending. When it was resolved, we got the fulfilled. And when something went wrong, we got the rejected. Now, the cool thing is we also saw with promises, we have this lovely syntax where the then, since the promise is just an object, when the promise resolves, it fires the method then. And when the promise is rejected, it fires the method catch. Pretty neat. Pretty neat. Now, let's get paid by everyone again. But this time, let's use the promise syntax so we escape callback hell. So let's get paid by everyone, and here is my code. I know this looks a little daunting at first, but I promise you it's not that bad. Bog, yes. Yes, yes, yes. All right. So there are ways to do something like promise.all. We'll get into that a little bit later. But I wanted to show you this chaining syntax. We can do this chaining syntax really easily, right? So here's my chaining syntax. And let's take a look at this. I'm actually going to go to my text editor. I'm going to comment this out. I am going to uncomment this newer code here. That's in the slides, but oops, sorry. Now, this isn't something that we would really do. This is for demonstration purposes, but it works. All right, there we go. All right. So here's my code. I actually like it in the slides. It's a little bit cleaner to see. Alrighty. Every single one of our houses is now a what? Every single one of our houses is now a what? Chat, what is every single one of our houses now? Yeah, it's all a promise. Every single thing is a promise. Nothing's changed here. It's all a promise. But if we look at it, house 1 is a promise that has a web API set timeout set to 1 second. Then our second house is going to wait 5 seconds. And then our last house is going to wait 2 seconds. So if this was synchronous, right? If this was synchronous, right? We would expect house 1 to run, then house 3 to run, and then house 2 to run, because this is 1 second, 2 seconds, and 5 seconds, right? But what we can see here is since all of our houses return promises, we can actually use the then syntax to wait. Okay, we can use the then syntax to wait. So let's go ahead and take a look at what this will actually do in the browser. So if I refresh, after a second, house 1 loads. After the 5 seconds, house 2 loads. And then after the 2 seconds, house 3 loads. All right. It's starting to look like synchronous code. Exactly, 3. It's starting to look like synchronous code. If we look at this and we look at these thens, this looks synchronous, right? Meaning that like it's going to go from this one to 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 this one, right? Like it's just in a row, right? It's just reading top to bottom here. So what happens is house 1 runs, the promise resolves, and that message is put into data. So the cool thing is we see that first paper delivered to house 1 in the console. Then we chain, and in that chain we call house 2. And the cool thing is that house 2 resolves, and we grab the data from house 2. The cool thing after that is that we call house 3, it resolves, and we get the data from house 3. And the really neat thing about this is that it's running, it looks synchronous, but it's running asynchronous. Like we have all these asynchronous tasks that are running, but our code looks synchronous, one after another, right? But chaining don't read too good. The chaining still looks a little messy. The chaining still looks a little too messy, right? Like if we're looking at it, I mean, like, yeah, it makes sense. It makes sense. Like, I get it. But it doesn't look like JavaScript. Does this look like it doesn't look like JavaScript. Like, it doesn't look like the functions I'm comfortable writing. It doesn't look like the syntax that I'm comfortable writing. It works. It's doing its job. It's waiting for these asynchronous tasks before moving on, right? But it doesn't look like the JavaScript we're used to, right? So, I want my asynchronous code to look synchronous, and I want it now. I want my asynchronous code to look synchronous, and I want it now. But you know what? You can't get everything you want in life immediately because we're going to take a break. Let's go ahead. It's my money and I want it now. Yeah. Let's go ahead and take our break. We're at the top of the hour. Major, yeah. Let's go ahead and take our break. We're going to put 5 minutes on the clock here, folks. If you're new here, we like to be healthy. We're engineers for the rest of our lives, not just for these 3 minutes. We want to make sure that we're taking healthy breaks. We're getting up. We're moving around if we're able. We're stretching. We're letting our eyes relax. I'm going to put 5 minutes on a timer here. I'm going to bring that timer over. We're going to have 5 minutes on the clock here. I kind of like the GIF. Let's keep the GIF on. There we go. 5 minutes. Let me put some wonderful break music on. I'm going to go ahead and run ads so that folks joining us after the break don't have to wait. So, unfortunately, those ads are going to run. If you don't have a sub or gifted sub, you're going to see the ads. I apologize, but it helps more folks be able to join our community without having to sit through them. And you should be taking a break anyway. Like, get up. Don't look at me. Ads are live. Thanks for everything tonight. Hey, I'm glad you're here. Hope you guys are learning some fun. I hope your brains are melding. The stuff we talked about earlier tonight blew my mind when I first learned about it. You're telling me that document.querySelector is not part of JavaScript? Wait a minute. What? Drake, thank you. My brain exploded. Let's say I think it's a little bit easier. Sour dev. C# async melted my brain first. Tito live. Hey, welcome. Go ahead and enjoy that reward, Trizzle. All right, folks, we got about 3 minutes, 40 seconds left. Take your break. If you're just popping in, we always like to take healthy breaks, meaning that we get up, we move around, we stretch, we let our eyes focus on something out in the distance. If you're new here, go ahead and give us a follow. We're live every Tuesday, Thursday, Sunday. We're running a free 30-week software engineering bootcamp. You can join us. This is the best day to join us. We just did a review class on Sunday. That whole review will be posted on YouTube very soon. It's here in the VODs. It's the VOD right before this one. Watch that. Get caught up. Join us live. We'd love to have you. Join our Discord. !point Discord. Thousands of folks all learning how to code and helping each other. We'd love to have you. Async is non-blocking. Erica, yeah. Is it more common to be writing promises or consuming them? Almost universally, you'll be consuming promises. It's kind of rare for me to ever create a promise, like using that promise syntax, especially. Like, I'm like 99% of the time consuming them instead of actually like writing them. Hey, Zevin, I appreciate that. Thank you so much. So Trizzle, it is synchronous. That's the problem. The problem is that it is synchronous, so it would block. It would like wait. Like we would want to like imagine like if you like imagine like you clicked something and then you had to wait before you could like scroll, right? Like you click a button and you have to like wait before you can scroll. Imagine like if you tapped like on Instagram and you just had to wait a period of time before you could like scroll to another image. So the problem is that JavaScript as a language is synchronous. It is blocking. And the cool thing is that when we run it in the browser, we get access to these web APIs that can do asynchronous stuff that JavaScript really can't do too well by itself, right? The problem is eventually those asynchronous tasks finish and they send us stuff back. How do we handle that stuff? Well, that's what we've been seeing with callbacks and promises, and we're about to see something else. Like, how do we handle that data that we got back? That's what we've been doing for the past couple minutes there. Now, on Thursday, we're going to go into a little bit more deeper about like what this means, like what is like single threaded versus multi-threaded, like what does synchronous really mean? Like how does JavaScript handle this stuff in the different environments that it runs? We're going to go deeper into all that, but I don't like to come out the gate with that. I think it's a little too much for like your first dip into the back end. And so we're building up to that. We'll get there on Thursday. Hey, Will, appreciate that. Hope the dinner went well. Now, since we're on break, we can talk about a little bit. Having something that's single-threaded versus multi-threaded can use less resources. There are some perks that are going to come as we start to realize on Thursday. Tito, that's great. Welcome. Salad and pasta, that's the wave. Alrighty, folks. Come on back from the break. Hope you had a good break. Come on back. Come on back. Home stretch, folks. Home stretch. Got like one more big concept to cover. And then we're going back end, baby. We're going back end. All right, come on back. Hope you had a good break. I'm going to chill the music. Chill the music. All right. No after class tonight. I think we're going to hit this last topic. And we're going to hit the back end. And we might end up, like I always say, we might end a little bit earlier. Then we might end up going for the full 3 hours. But I think we might have a little bit of breathing room, but no like Remo or anything tonight. All right, welcome back. All right, I want my asynchronous code to look like synchronous code. I want it to look like, that needs to be an emote. That needs to be the emote. Oh, I think not early. It needs to be like an emote. Like Leon says we're going to end early. Nope, not early. I want my asynchronous code to look synchronous, and I want it now. Async Await. Async Await is just a way to handle those asynchronous responses. We're handing stuff off to those web APIs, right? Those set timeout, those fetches, all that fun stuff. We're handing off stuff to them. Eventually it comes back. And we want to be able to handle the response that we get back. All right. We want to be able to handle that response that comes back. Now, the cool thing about Async Await is it's just promises underneath the hood. It's just promises underneath the hood. The MDN, which is a great resource, says it's just syntactical sugar on top of promises with the purpose of making asynchronous code easier to write and read afterwards, right? MDN has some brilliant articles on Async Await, brilliant articles on promises. Highly recommend you check them out. Cool. So it's just syntactical sugar, just gives us a new way of kind of dealing with the stuff that's coming back from all this asynchronous stuff we're doing in the browser. Cool. The cool thing is that we're going to have this keyword called await. And all await does is it waits for an async process to complete inside an async function. Don't let that overwhelm you. Await waits for an async process to complete inside an async function. What else have we seen that waits for an async process to complete? We saw one other thing that waited for an async function, an async thing to complete, and then that ran. What have we seen before? Yeah. We saw our promises with the then keyword. Sorry, the then method, right? That then fired when that promise resolved, right? When that promise resolved, we saw the then fire. It's a similar concept here. Await waits for some async stuff that we handed off to those web APIs to complete inside of an async function. So here is the code that we just saw a few seconds ago. And the cool thing, let me get out the way here. What? I do this. There we go. Aha. Look at me go. Never really thought to do that. It took me, 6 months to figure out I could do that? So here's the code. All this code here is the same. But this code, little bit different. So let's go ahead and take a look at this in my text editor. I am going to comment out this code, and I'm going to uncomment the new code that we have here. Wonderful. And so what you're going to see is these functions are still the same thing. These functions are still returning promises. Nothing new here. Still returning the promises. But we get this lovely new function here. And the only thing that's different between this and a normal function is that it has this lovely async keyword. Okay. Let's go ahead and save this and run this in the browser and see what happens. And we'll come back to it. Oops, sorry. There we go. 1, 2, 3. All right. So we were able to accomplish the same thing we did with our then chaining, right? We were able to get paid by each house before moving on to the next house. These asynchronous things that are happening, right? These web APIs that are asynchronous and they're happening in the browser, right? Those things that are happening, we're able to kind of like wait, and our asynchronous code, like our code that's just like running, it's taking anywhere from like one of our promises is taking a second to resolve. One of our other promises is taking 5 seconds to resolve. Another one of our promises is taking 2 seconds to resolve. We don't care how long any of that asynchronous stuff takes to resolve. With this syntax, it looks like we're writing synchronous code. All right, so here we go. We're going to await house 1 and store that in house 1 wait. We're going to await house 2 and store that in house 2 wait. We're going to await house 3 and store that in house 3 wait. And then the cool thing is, I can just console log these bad boys right here. I can console log house 1 wait, console log house 2 wait, and I can console log house 3 wait. Now, if I had been writing like normal code, and I go all the way back to the example that we saw in the very beginning, these console logs shouldn't wait, right? These console logs shouldn't wait. Like, we should see house 1 be printed to the console log first. Then we should see house 3 printed to the console log second because it takes 2 seconds. And then we should see house 2 finally be printed to the console log because that takes 5 seconds, right? But when I use this wonderful syntax, it just knows to wait. It waits until it gets this data. It waits until it gets this data. It waits until it gets this data. And then I'm just able to console log these bad boys 1, 2, 3. So my code that is definitely running asynchronously now looks like I'm writing synchronous code. It looks like I'm just reading 1, 2, 3. It looks like I'm just reading top to bottom. It looks like normal JavaScript, right? Zora said, why didn't we learn this first? Well, chat, why didn't we learn this first? What is this async await syntax sitting on top of? What is it sitting on top of? Promises, right? It's sitting on top of promises, right? It's sitting on top of promises. And promises were a great solution to what problem? Promises were a great solution to what problem? What were promises a great solution to? What problem? I like everybody. Everyone doesn't trust. Everyone doesn't trust the auto mod, so they're saying callback heck. Yes. Yeah. So we had this callback hell where everything was nested. It was ugly. It was horrible. Ugh. Then as JavaScript progressed, we got promises, which are just objects, right? But they have this ability to resolve asynchronous stuff. And that asynchronous stuff either resolves or gets rejected. And we can do stuff if it gets resolved or rejected. And we had the syntax that was then. And when we had a bunch of them, we wound up chaining a bunch of thens, right? We wound up chaining a bunch of thens. And yeah, it worked. It just didn't look good. It didn't look like normal code that we would want to write. So then we got with ES7, I think it was ES7, 2017, we got this idea of async await, which is just syntactical sugar on top of promises, right? On top of promises. Was it ES8? Okay, yeah, ES8. Syntactical sugar on top of promises that makes our asynchronous code, like the stuff that those web APIs that are running in the browser that are taking a long time, we don't see that. This just looks like it's synchronous. It reads this one, then this one, and then this one. Look at that, folks. Look at that code. Look at that sexy behind code. Look at that code. Look at that code. It is nice, isn't it? It's real nice. It's purty. It is real nice. Look at that code. Cool. So, I need something real. Somebody, come on, you know me. What is the reason? What is the reason, right? Rudy, I got you. What is the reason, right? I need something real. Leon, you've been talking about getting paid. You've been talking about paper persons. You've been, but why? Why would we use this? When can I make my asynchronous code look clean? When can I make my asynchronous code look like it's synchronous? When will this actually help me in my real life? Well, you've all been using it, folks. You've already been doing it. Let's code an API request using async await. Let's clean this up. Let's look at it. Let's get into it. All right. Here's the code. Here's the code. Here is our fetch. Right? No weird chaining. This just reads like some nice, it looks like synchronous code. Look at this. Look at this syntax. Look at this. It's pretty, isn't it? All right. We got an async function. It says async. And then we have our awaits inside. So the cool thing is we can await the fetch. And a fetch returns a what? A fetch returns a what? Chat, what does a fetch return? It returns a promise. It does indeed. So the cool thing is we can await the resolution of this promise. When the promise resolves, whatever value that promise resolved with is stored in res. right? So I can await it. And then the cool thing is, just like I could do inside of my then chain, I can await mapping all of that data I got back from the promise into JSON. And then the real neat thing is I can just go ahead and console log that data. No chaining. It reads just like normal JavaScript. This looks like good, clean JavaScript. It looks synchronous. I'm just writing my code from top to bottom, folks. I'm not trying to worry about like, all right, this API request might take some time. How do I like nest my fetches? Like, nope, I can just wait stuff now, folks. What is asynchronous, right? Now looks synchronous. It looks nice. It looks neat. Chef's kiss. Beautiful. It's beautiful. All right. Back end, baby. So what I would like for you to do before we get to the back end, though, is I don't want to take time. I don't want to like. I was gonna ask you all to take some time to code out an API request using Async Await. The answer's here. I'm going to ask you to do that for homework. So for homework, I want you to just practice this syntax. I want you to practice this syntax to make an API request. Pick any API that you've used in the past. Get some data back from the API, but using this new syntax. And there's one thing that's not on the board here. What if the promise is rejected? What if the promise is rejected? Have we set up any way to handle the rejection here yet? No, we haven't. So there is a bit of syntax that I'm going to need you to research. There is something called a try and a catch that we can use inside of our async functions that work similar to the catches that we had with our normal promise syntax, the normal chaining. So I want you for homework to get an API working that you've had working in the past using this new syntax, get some practice typing it out, but also figure out how to catch an error. Cool. Back end, baby. Ooh, you feel it? You feel it? Y'all ready? Y'all ready for some back end? Let's go. Let's become full stack developer. You ready to become a full stack developer? Because I'm ready to become a full stack developer. Let's get into the back end. All right. Here's a question, chat. Chat, here's a question. Chat, here's a question. Does JavaScript have access to the DOM natively, like built in? Is built into JavaScript the ability to access the DOM? If you're here, put an answer in chat. Go ahead, type. Just give me some typing. Give me some type. If you've never typed before, put a yes or a no. I don't care what you put. Put a yes or no. If you're sitting here watching, you have the ability to type, and you have never typed in chat, here's your chance. Give me a yes or a no. You can look at the chat. The chat's right. It's easy. It's easy. Just type no. Just type no. Go ahead. Type. You can do it. I believe in you. No. Beautiful. All right. So does JavaScript have access to the DOM natively built in? No. Nope. Doesn't the JavaScript itself does not have access to the DOM. Nope. JavaScript needed web APIs to handle all the asynchronous stuff we've been talking about and a bunch of other stuff in the browser. So JavaScript needed web APIs to handle all that asynchronous stuff because JavaScript itself can't really do that asynchronous thing right. Okay. Now, something really interesting is, where is the JavaScript that we've been writing running? Where is the JavaScript that we have been writing running? It's not a trick question. It's kind of already on the screen. Where's the JavaScript we've been writing running? Yeah. The browser's a program on your computer, right? Just like Microsoft Word is, or if you have Discord installed, like those are programs in your on your computer. Well, JavaScript is running in that program, right? And there's something really interesting that's happening, and it's called that JS is called it's sandboxed, meaning that it's sandboxed in the browser, and it doesn't have access to anything else. So the JavaScript that runs in your browser, does it have access to the files on your computer? No. Why would JavaScript that runs in the browser having access to the files on your computer be like a really bad idea? If JavaScript that runs in your browser, yeah, security, right? Like if I could send you to a website and you load my JavaScript, the JavaScript I run, if it could just start like grabbing files from your folder, it goes into desktop, it goes into personal, it goes into the P folder, and it starts grabbing stuff, right? Like, you don't want JavaScript to be able to do anything outside of the browser sandbox. And the cool thing is that that browser sandbox comes with a lot of cool stuff. It comes with all those web APIs that enable us to do that asynchronous stuff, but it's stuck there. So there's a really important concept to understand here. JavaScript is a programming language, but it can only do what the hosting environment allows. Okay, not the OnlyFans drafts. So JavaScript is the programming language that we're using, but it can really only do what the hosting environment allows. Does the browser, which is the hosting environment for our JavaScript thus far, does the browser allow the JavaScript we write to access files on your computer? Well, thank you for the hydration. Cheers to you. Nope. The hosting environment that we have been using this entire time has been a browser. And that hosting environment is sandboxed. It does not let the JavaScript we write escape it. It doesn't give it access to anything else on your computer. Okay? Now, every once in a while, somebody figures out how to escape the sandbox and they build exploits. Those are big. If you ever find an exploit that enables JavaScript to escape the sandbox, let me know. I will make you filthy rich. We'll split it 50-50. I know the right people. You just give me a good old DM and we'll figure it out. Okay? All right. We'll work it out. Sheena says 75-25. I know the people. You don't. 50-50. It's a fair deal. I'm going to make you rich. All right. So here's an important question. So far, we've been talking about our client-side code, the JavaScript that's running in our browsers. But we want to get to backend today. And so we know that we have two different types of computers. We go all the way back to the first class, or if you joined us on Sunday, we talked about this. We have two different kinds of devices that are out there on that wire. What are the two devices that are out there on that internet wire? Yeah. We got client-side devices and servers. Hold on. There we go. We got client-side devices and servers. So far, all of our code has been running on a client-side device, sandboxed in a browser. Pasta Tofu, thank you for the hydration. Cheers to you. So I got some questions for you. What might a server need that our browser might not need? What's something that the server might need that our client side code might not need. Yeah, you got some good guesses here. I like these. Yeah. Some of you are hitting on the big ones. Our servers are going to need two like really fundamental things, like two really big things: disk access and network access. Disk access is like the ability to read files, right? Why would a server need to be able to read files? Why would a server, stay with me here. Stay with me. Why would a server need to be able to read files? Let's think about this. Go all the way back to the first class. Put yourself back in the day. Yeah. It's literally its namesake. A server is made to serve files. So if a server is made to serve files, it better have access to files, right? Like if a server is going to serve up files, if it's going to eventually serve up a bunch of stuff, HTML, CSS, JavaScript, whatever, if it's going to serve up those files, it needs to be able to access those files. And those files don't exist in some magic ether, like they're not being plucked out of the air. Those files are stored on a hard drive or a solid state drive or some sort of memory. And then there's one other thing that a server does. A server, in one word, does what? A server, in one word, does what? Loves us. It serves. So, if a server is going to serve, it needs some sort of network access. It needs the ability to hear the requests being made and be able to respond with files, right? So if we're talking about a server needs two fundamental things. It needs the ability to like access files on some sort of disk and then being able to send those files to you when you request them. When you go to Domino's.com, the server needs to be able to hear that request, say, all right, we're going to get you this file, and this file, and then respond with those files. All right. Does JavaScript, one more time, chat, does JavaScript have access to the disk and network access natively? Does JavaScript have, right? Does JavaScript natively have the ability to access your disk or your network? No, it does not. So, what if there was a hosting environment that allowed JavaScript to have disk and network access? What's the hosting environment that we've learned about so far? What's the hosting environment that we've learned about so far? The browser. Exactly. The browser is the only hosting environment we've seen so far. The browser enables us to take JavaScript, run it in the browser, and it gives us access to all this cool stuff, all these web APIs, all that fun stuff, right? It gives us access to the DOM. But what if, hey, Freckled Science, what's going on? How you doing? How you doing? Oh, you're in for a treat here, folks. You're in here for a treat. Hope your stream went well. What have you been building recently? Freckled Science, what have you been building recently? What have you been working on? I saw like a lot of gluing the other day or something like that. Like you had a bunch of like sheets of paper. There's like yellow stuff all over them. I didn't see what it was though. Welcome, Raiders. Hope you're doing well. Hope your stream went well. Hope you had a lot of fun. You're here just for the big reveal, folks. You're here for the big reveal. What? That's awesome. I've been making thousands of cards to send to Indigenous kids in Canada for science experiments. That's wild. If you haven't been followed Freckled Science, we've rated them once before. You should definitely follow them. Really cool experiments. Great chat. I love hanging out there. Good stuff. All right. So we've been building up to something, folks. We've been talking about a programming language called JavaScript, right? And the JavaScript we've been normally writing for the entire program so far has been running in a browser. And when it runs in the browser, we got access to all these goodies like the DOM. Now, we know that the browser doesn't enable us to have access to a disk or network. If we are going to build a server, thank you, Alyssa. Thank you for the link. Folks, take a second. Follow Freckled Science. The link's in chat. Go ahead and give them a follow. If you weren't there for the last raid, definitely go ahead and give them a follow. All right. What if there was a hosting environment? We saw the browser as a hosting environment that allowed JavaScript to have disk and network access. Remember, if we want a server, we want something that can listen to our dominoes.com requests, grab the files that we need from the disk, and respond with those files, right? If we want that, what if there was a hosting environment that allowed that to happen? This is your 10-second warning. It's going to be loud. It's going to be music. There's going to be dancing. What if it was a hosting environment that allowed this to happen? There is, folks. It's Node.js. Node. Hey, let's go. Where's Bob? Bob needs to be here for this. Hold on. Just Bob on the head. Hey, turn up. Bob, we got the node, baby. Let's go. No, baby. That's what we're talking about. Let's go. Oh, second drop. It's coming. Oh, you feel it. You feel the node. You feel it. Ooh. Let's go, baby. Hey, get it. It's Node, baby. It's back end. It is the back end. All right, it's Node. Node is that environment where we can run JavaScript and get access to things like the disk and the network. And if we have JavaScript running in an environment where it can get access to a disk and network, we can build what, chat? What can we build? If we have JavaScript running in an environment where it can get disk and network access, what can we build? There we go, chat. We can build servers. And if we can build servers, we can build full stack web applications. One more time. Hold on. 10-second warning. This is big, folks. This is big. We've been waiting to get here. 5 seconds. Whew. It's Node, baby. It's Node. It's Node. Let's go. Bob's hype. I'm hype. You're hype. Let's go. Node, baby. We're here. Back end. Feel it. It's the back end, baby. 30 classes, but we're here. Start at the bottom, but we're here, baby. Who's ready to become a full stack developer? Who's ready? We're adding some stuff to the resumes tonight, folks. Woo! Back that stack up. I love it. Back that stack up. I'm putting that in the slides. I'm going to edit the slides afterwards. Back that stack up is going in there. One job, please. I'm ready. Somehow I survived till now. Hey, let's go. All right. So the hype is real. We've made it to the back end. We understand what the hosting environment is. We understand that if JavaScript can get access to the disk and the network and all that fun stuff, we can build servers. And if we can build servers, we can build backend, and full stack web applications. So with all that hype, you go to Node.js's website and you see this. Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. Node.js is a what the fuck's a runtime? Built on Chrome. Why did they put this on their website? Node.js is a JavaScript runtime built on Chrome's what's V8? I loved V8 when I was younger. It was like I didn't like vegetables, but I liked V8. JavaScript engine. Where's Cardi B at? What does it mean? Where's Cardi B at when you need them? All right. I don't know why they chose to write it that way, but the same shit that lets you run JS in the browser can now be used to run JavaScript on servers, desktops, or wherever else. So the hosting environment, that's our runtime. And the cool thing is that like JavaScript, the reason it was able to run in the browser, like the reason why the browser hosting environment worked, right? Like the reason why we were able to run JavaScript in the browser is in Chrome, it was using something called the V8 engine. That was the thing that was like taking our JavaScript and breaking it down into something that the computer could understand. So if you've been using Chrome, you've been using the V8 engine this whole time. That's what's been enabling us to run JavaScript in the hosting environment that was the browser. Now, since we don't have the browser anymore, we need a new hosting environment, a new environment where we can run our JavaScript, but maybe get some access to some other goodies that we don't get access to in the browser. And the cool thing is that same engine that the browser used, we can use that engine via Node. So when we go back to this, Node.js is a is a hosting environment built on the shit that lets JS run in the browser. All right, so Node.js is a hosting environment built on the same shit that lets you run JavaScript in the browser, but now everywhere else. Let's go. Now, the cool thing is, if you're new here, my mother was the queen of finding me free stuff to do. Every Saturday for years, I went to learn how to draw with a group of nuns, and you see that it didn't help much. That's what the nun spam is for. All right. I don't know why they don't say this. Why can't they just say this? All right. Chat, why is Independence Day a true story? Chat, why is Independence Day a true story? Checking out Bob. I hit Bob on the head accidentally. Bub. Yeah, I love that Bub is what we use. Binary upload boom. If you're new, aliens came. Jeff Goldblum wrote a computer virus that took down the aliens' like shield system. We nuked them. We won America, right? But how is Jeff Goldblum able to write a programming language that a computer could understand? Well, Jeff Goldblum reverse engineered that code all the way down to the things that any computer could understand, like universally, like on and off values, built it back up to some simple logic, and then used that logic to write the program that the alien ship understood. We injected the virus, we took down the mothership, and we won America. Cool. Now, the really cool thing is that V8 engine that's enabling JavaScript to run in the browser, and now that engine that's also going to enable us to run JavaScript like elsewhere, that engine is doing that. It's like taking the JavaScript that we write and breaking it down into something that the computer can understand. Now, you might hear this called like a compiler. There are lots of like fancy terms for it, but the idea here is that that engine is taking the JavaScript we're writing and breaking it down into something that the computer can like actually understand. Cool. And the cool thing is, rebooting rocketry. Hey, thank you for the sub. I appreciate the support. Thank you for hanging out. All right. Now the cool thing is, just like browsers came with those really cool web APIs, the things that we just thought were part of JavaScript, like the DOM or set timeout or set interval or anything else on this massive list of APIs that come with the browser, right? The cool thing is that Node also comes with a bunch of stuff. And one of the really cool things that it comes with built in, like straight out the gate, is HTTP or network access. It's a collection of functions. We call them modules. It comes with a bunch of modules that are built in. Modules is just like a fancy word for a collection of functions. Think of like a file that has a bunch of functions in it. That's what a module is. So Node comes with a bunch of these files that have a bunch of functions in them that can do some of the heavy lifting, right? It comes with a module that can handle network access. It comes with a module that can handle file system access. And the really cool thing is you can access millions of other packages, like people like collections of one or more custom modules that other people have written via something like NPM or the Node package manager. So not only do you get JavaScript running in a new hosting environment, but that hosting environment comes with access to the network, access to files, and access to millions of other things that folks have taken the time to write and share publicly on a package manager like NPM. Boom. Now, I really don't know where this image came from. If somebody actually comes across where this is from, please let me know so I can cite them. I really like this image because it shows you what's happening here. JavaScript is the language that we're writing. And the cool thing about the JavaScript that we're writing is that it is using a new hosting environment. Whereas JavaScript we've used thus far has run in the browser, this JavaScript, right, is using a hosting environment that's given to it by Node. And the cool thing about this new hosting environment is that it has the same engine. So it can like read the JavaScript that we're writing and relate it to like the machine, and like the machine can understand what we're writing. But it gets access to asynchronous stuff as well. And it gets access to a similar event loop that we had in JavaScript that we're going to talk about on Thursday. It also gives us a lot of these bindings. Like it gives us these built-in things that enable us to talk to the network or enable us to talk to the file system. And those things aren't actually written in JavaScript. They're written in C and C++ because those languages are super fast, right? They're super fast. And so the cool thing is we can write JavaScript, but take advantage of all this really cool stuff that's really well optimized, has been around the block for ages, and is in super fast. So we write the JavaScript that we're used to, but now the JavaScript that we're used to can not only run in a browser, we can now run it on a server, we can run it on the desktop, and we can run it in all these new areas thanks to the Node environment. Whew, you feeling that, folks? All right. Now, there's a bunch of other stuff here. We can talk about call stacks. We can talk about callback queue. We can talk about node modules more. Talk about event loop. But we're going to get to all that stuff on Thursday. So what I would like for you to do is, you don't have to do this right now, but when you're done class tonight, it's time for you to install Node. You need to get Node installed on your machine. This is a rite of passage for any developer to set up their environment, to like set up their computer. Now, there are many ways to install Node. It's up to you if you want to do some of the more fancy ways. There's NVM, there's like the newer one, I forget what it's called off the top of my head. Or you can just go to the Node website, nodejs.org, and click one of these nice green buttons. Right? For your first shot at this, if you're not really comfortable in the terminal, you've never really used maybe like a Unix-like architecture before, if your first experience with the terminal was like our class, maybe don't try and do one of the fancy ways. Maybe just click the button. If you're up for a challenge and you want to try using Yarn, you want to try using a homebrew, you want to try using an MVM, you want to try using any of these other things, knock your socks off. When you get stuck, come to our general code help channel. We'll help you get unstuck. But for other folks that don't feel that quite comfortable yet, just click one of the buttons. Button's nice. Yeah. Now, the cool thing is that you're going to see that there's two different options here. There's an LTS and there's a current. And this LTS and current is a really interesting thing to learn about. With a lot of software, you're going to have multiple releases. And these multiple releases are kind of like where you want to be doing your work. So you could have an LTS, which stands for long-term stable. You can have a current, or you can have like a nightly. So something really cool about, say, something like Chrome is that there are 3 channels. If you're just using Chrome like normal, you're on something called a stable channel. But if you want it like the cooler new features, you could switch your Chrome from the stable channel to the developer channel. And then you get all these new features first. The problem is sometimes things don't work, right? Then if you really want to live like by the seat of your pants here, you can install the nightly version of Chrome. And literally every night, all the new stuff hits. And sometimes you can't click on things. That's maybe an exaggeration, but you get these really weird bugs. And so the cool thing is you can choose your own flavor here. When it comes to Node, there's really 2 big decisions, either LTS or current. We're going to use LTS throughout the entire rest of program, just because it's what's currently being used, and we don't really need any of the cutting edge, super bleeding functionalities of Node. We're just gonna use kind of like the stuff that's been out for a while. The cool thing you can see here, though, is that the LTS version will be the active version through 2021, and then it's going to go into maintenance. And what maintenance means is for like the next, I think it's like 30 months they support it. For the next 30 months, if you're using that version of Node, you'll get bug fixes, security patches, all of this wonderful stuff. Okay. Now, why is this important? Why is like this maintenance schedule important? Like why did they put this this is like the first thing on their site? Why is this schedule important? Like why does it matter, chat, that we know the active window, the maintenance window? Why is this important? Yeah, security is a thing here. Planning ahead, absolutely. All right, so here's the thing. You all are about to transition. You didn't realize you're about to go through a change, but you're about to go through a change tonight. Before, you were just writing code for yourself. You didn't have to really think about how your tic-tac-toe game was going to run a year from now. Right? You didn't really have to worry about like how your Pokemon API is going to work in a couple of weeks. But as you start to build full stack web applications, specifically for like employers or clients, or even just the ones that you want to keep around for a while, you want to know the software you're choosing to build your application with is going to be supported. And so that's why this release schedule is really important. This release schedule is important because it lets you know, all right, here's how long it's going to, this version is going to be supported. And as a team, we can plan to say, all right, in January of 2023, we're going to need to spend some time thinking about transitioning to node 16. So it enables you to think in the future, enables you to get your work done and know that the tools you're using to build will be supported into the future. That's really important. And I like that they put it right up front. All right. So tonight, before we leave, I want to show you a very simple node server. Here is the code for a very simple node server. Evolved line, what's up? Here's a very simple node server. I am requiring the HTTP module and the FS module, which means I'm just getting those modules. I'm storing them in HTTP and I am storing them in FS as just variables. The cool thing is a module is just a series of what? It's just a collection of what? A module is just a collection of what, chat? Just a collection of functions. We might call them methods, right? Which might give us a hint as to how the modules are structured, right? Just a collection of functions. And so the HTTP module, you can see, has access to a create server function. Somewhere in that module is a function called create server. And the cool thing is inside the FS module, there is a function called read file, right? And so we know that those modules are a collection of functions and we can use them. So HTTP has all of these different functions that we can use, and FS has all of these different functions that we can use. And so, yeah, they can be a little bit complex, but this is all we need for a very simple server. So I'm going to go ahead. I'm going to save this. I'm going to go ahead and open it up on my my computer here. So here I have the code I have in the slides, and it is a very simple, it's just a very simple JS file called demo.js, and I have a very simple HTML file called demofile.html. So let me show you demofile.html. Very simple HTML file, just has an H1 that says hello world, right? And what is this very simple server doing, chat? Can anybody figure out, chat? What is this very simple server doing? Can you figure out what this very simple server is doing? Yeah, it's just serving up your HTML. Exactly. It's serving up this HTML file. So if we look, all right, let's look at this. Go ahead and create a server. Great. This server can now hear requests and it can generate responses. Beautiful. We're setting up a server. It can generate requests and it can generate responses. Cool. So what I am doing here is that when I hear a request come in, look, this is all nested inside here, right? When I hear a request come in, I want to run this bit of code. And this bit of code is going to use the file system module to look on my disk for demofile.html. Once it finds that demo file HTML, like once it finds that HTML file, look what it's doing. It's responding with it. It's responding with a header that lets me know it's an HTML file. It's saying, go ahead and send that data and then let everything know that it's done. So all it did is it heard a request and it's going to respond with this file. But I have to start the server. This file just won't run on itself. It won't run on itself. I have to start the server. So I'm going to show you how to start a very simple node server. I am going to, the cool thing about VS Code is that there is the terminal built in. So I'm just going to open up that terminal. but you could just use any terminal that you have access to. I am in my class 30 folder. So I am going to move into my node intro demo. Oops, sorry. Am I in the wrong folder? Let me see. I'm doing ls real quick. I'm going to cd into my node intro demo folder. And then once I am inside of this folder, it's a very simple command to run this file. It's just going to be node and the name of the file. There we go. Now, you'll notice something very interesting here. Chat, what happened here? What happened there, chat? I didn't get a prompt back. It's like waiting. It didn't get a prompt back. Do you know why it's waiting? Because my server is running. My server is running. It's not giving my prompt back because it's running a server. There is now a server running. So the cool thing is, if I go to a special URL called localhost 8000, if I go to a special URL called localhost 8000, so let me go up here, localhost 8000, that's where my server resides. Oh, I have two servers running. Hold on, let me kill my other server. I had a couple running here. Let me kill this one. Let me kill this one. There we go. All right. I go to localhost 8000. That's where my server is running. And look what it serves up. Chat, what did it serve up? Let me refresh. What did it serve up? It served up my HTML file. It served up my HTML file. Let's go back and kill this server. So if I want to kill this server, I'm just going to do Control-C. So now you see I got my prompt back. I got my prompt back. And so now I know my server's not running. My server's not running anymore. So if I go back and I refresh, RIP, server cannot be reached. I can go back and rerun it. Now the server is running. I go back to localhost 8000. Boom. Now, what's that 8000? 8000 is something called a port. My computer can run many servers, but I want to be able to listen on different ports for different servers that are running. So I'm just saying, listen on 8000 for this specific server. But if I started another server, I could run it on any other number, really, and it would work. And so I could have multiple running on my machine. Cool. What I want you to do is get this code running. Yeah, it's arbitrary. You can pick what you want. Right? I want you to get this code running, because when you get this code running, warning, 10-second warning. When you listen, when you get this code running, here we go, baby. When you get this code running, you are a full stack web developer, folks. You are a software engineer. You can build back-end web applications. You can build front-end web applications. You can build full stack web applications. Let's go, baby. Let's go. You get this code running tonight, you're a full stack web developer, baby. Full stack web developer. You deserve it. You owe you. Get this code running tonight. feel it, folks. You feel the power? You feel the power? You're now full stack web developers, baby. Oh. The drop. You're full stack, baby. So tonight, you can enter into the hallowed halls of full stack web development. All you got to do is come here and get this file running. Get Node installed. Once you have Node installed, just run the file and you will be a full stack web developer. So, hope you had some fun tonight. Hope you understand a little bit more about how JavaScript runs, how it's able to run in different environments like the browser and now Node. Hopefully you saw that some of the things we thought were JavaScript were all lies, right? That it was really web APIs that the browser was giving us access to. We saw that JavaScript's probably not really the best at this asynchronous stuff, but the different environments give it access to asynchronous things, like through the web APIs. But then JavaScript needs a way of like handling the stuff that's coming back. And so the way that it can handle stuff that's coming back, right, is through callbacks, which were the old school way. Then with, yes, we said, I think it was 8, we got the promises. But the promises really didn't read, right? They didn't read like synchronous code. It didn't look like the JavaScript that we were comfortable with, right? It didn't feel like the JavaScript we were comfortable with. So we added Async Await. And then we said, all right, now we learn all this stuff. Cool. What's a different environment that we can run our JavaScript in? And we moved to Node. And tonight, you're going to get Node installed. You're going to get this file running, and you will be a full stack web developer. You will be a software engineer. You will be a software engineer that can write client-side code, that can write server-side code, that is full stack, baby. So I need you to do something for me. When you get this running, and you get this file running, you gotta update your resume, folks. You gotta update your resume. You gotta put, I'm a software engineer, but I also got full stack web development skills. So, hope you had some fun this evening. Let's go ahead and do a raid. As always, we like to send some love and positivity to somebody else. Give them some follows, make their night. Let's go ahead and end with the raid. Hope you had fun. Hope you learned some stuff. I will see you all on Thursday, folks. I can't wait to start building even more full stack stuff with you. Let's go ahead and do a raid. So we're going to go ahead and raid a lovely person here doing some development. Hang with us. Alrighty, setting up the raid. It's coming through. Should be 15 seconds. Get those channel points. Alrighty, here we go. It's set up, folks. See you all over there. I'm going to hang out for a while. Hopefully you'll hang out with me for a little bit too. Thank you for a wonderful night. Hope you had some fun. Hope you learned some stuff. Let's raid. Good night, everybody.